Hello, Mr. Bossert here. Talking today about interest, simple and compound interest. Interest itself is it's another way to use percent, and usually dealing with money. It really is. Interest is dealing with if we talk about A equals percent times base, right? Percent of some number is equal to the new amount. Well, interest is an amount of money, right? And the base is something called, in the money world, it's called the principal, right? It's the starting amount of money, or the base, times the R, which is the interest rate, which is a percentage. But for interest, there's also a factor of time. So it's not the amount of money that is earned or owed is accrued over a period of time. And so a big difference when we're talking about interest is this factor of time that is involved. Alright, so we have just basically a definition, right? We have this formula that I just wrote on the last page, I equals PRT. The interest is an amount of interest, and it's equal to the P, which is the principal, and that's, you can think of it as the base or the starting amount of money. A lot of times it's the amount that's invested, or it's the amount of money that is used as part of a loan, times the interest rate, which is a percentage, right, times an amount of time. So a fun, easy way to remember the simple interest formula for interest is just I equals PRT, or I party. Another formula for simple interest, this is calculating the total amount in the account, principal and interest together, right? The principal and interest. And whereas in the first part, you're just calculating how much interest is earned, the A is talking about, so what is the total value of the account? Here the principal is still P, so A is the total amount that the account is worth, and P times 1 plus RT, or if you distribute this, A equals P times 1 would be P, plus P times RT would be PRT. So that's literally, move this here, move these other things out of the way. It's the principal and interest together. That's this down here. So this is kind of an easier way to write it. This is altogether principal plus interest. Interest is an amount of money earned or paid or owed in some financial transaction. Principal is a base amount of money from which the interest is earned or owed. And the rate is the interest rate. And it's usually given as an annual percent, so per year, if it's not listed. Okay, so we have an example here. If I put $1,000 in the bank, and my interest rate that I earn is 2%, and I have it in there for 5 years, how much money will I earn in interest? Alright, so my interest formula is I equals PRT. I substitute in for the P, the $1,000. The interest rate is 2% or 0.02, and the time is 5 years. So this would be, if I multiply all that together on my calculator, I get $100. So the principal is $1,000, and after 5 years, under this simple interest situation, my principal plus my interest, this would be 1,000 plus now the 100 that I've just found from this formula, would give me a total of $1,100. So supposedly after 5 years at 2% simple interest, my account would be worth $1,100. Okay, it would be worth the $1,000 that it started with plus another $100. This isn't really how the world works. So don't work on simple interest. Simple interest may be how they had to do it a long time ago. And here you're just figuring out the amount of interest one time, all right? And you're calculating interest once at the end of whatever the thing is. If you loan money to your brother or your sister, you may figure out interest this way. It's a simplified way. So you might say, if you borrow $20 from me, you're going to pay me 10% interest. So you're going to, you know, at the end of this month, and so your time period would be 1 month, and you're going to give me $22 back. That's 10% on top of the $20 that you borrowed, or something like that. Or you may borrow money from your parents for something that you really wanted to buy, and they may negotiate a simple interest. That's not exactly how it does work in the real world. Real world more works on compound interest. And if we kind of look at the variables are all the same. A is the total amount in the account, principal is the starting amount, R is the interest rate. The time is the amount of time, but it's the number of times that the interest is figured out or compounded. If I had, and you'll notice that the difference between this formula and the formula on the first page is that now the t is actually in the exponent. And we'll talk why about that is in a minute. But can I physically put my information through the system, right, through the formulas? Find the value of an account that starts with $5,000 and earns 4% APR compounded annually after 10 years. Okay, so, sorry, while I get rid of some of this other stuff. So compounded annually, all right? So find the value of the account. We don't know what that is, so that's X. Principal is $5,000 is the amount that I started with. The rate is 4% APR. APR is annual percentage rate. You might, like on a car commercial or something like that, and the guy, the really fast talker at the end says, 2.9% APR. That's annual percentage rate. Okay, so that's a typical rate is an APR, a per year, compounded annually. That means every year we're going to figure out how much money we're going to put 4% per year. So every year we're going to earn 4%. So the time here is going to be 10 years. Now if I put it into my formula here, A equals P 1 plus R to the T, and I knew I needed to use the compound interest formula because it says compounded, right, annually, and this tells me, annually tells me how often that it is compounded. Okay, so if I substitute in, all right, the formula 1 plus R, and 1 plus R, the 1 really has to do with the fact that because P is outside of here, it could be the principal, right? 5,000. So 1 plus R is 1.04, and then T is 10. So I've substituted in this. Now what's going on here is, if I say, well, in one year, how much is the account worth? If I go back to my simple interest, if I figure it out, P plus PRT be 5,000 plus 5,000 times 0.04 times 1 year. Okay, the 5,000 times 0.04 times 1. Let's see here. is 200. So in the first year, if I figured out the interest at the end of the first year and added it on, my principal and interest would be $5,200. So in year 2, my principal would no longer be $5,000. If I did the simple interest again, in year 2, my principal is now $5,200. And then I would earn 4%. My amount of interest, would be 4% of that times one more year. So in year 2, I'd now be working off of $5,200. Would be 208. So at the end of year 2, my account should be worth 5408. So here's year 1, here's year 2, and year 3, if I did it again, what I'm really doing is I'm multiplying the principal times the rate plus here. If I take out the 5,200 or the principal, it's 1 plus R, right? If I did 5,200 times 1.04, this would give me the 5,200 plus this would be 5,200 times 1, and then this is 5,200 times the 0.04, and that gives me the new total. So this is equal to 5408. If I did it again in year 3, now my principal would be 5408, and I multiply that by 104, which is 104%. And that makes sense because 100% would be the number, plus another 4% would be 104%. If I do 5408 times 1.04, that gives me 5624.32. So that's at the end of year 1, year 2, year 3. My thing would be worth 5624. In year 4, my principal will be 5624.32, and if I multiply that by 1.04, again, I'm compounding it 4% again at the end of year 4, and year 5, and year 6, and you'll see that I would do it how many times? Well, I'd do it 10 times. And so if I take my 5,000, but I I multiply by 1.04 10 times, that gets me to how this formula is generated, right? The T is the number or amount of times that you are compounding the information. And if I did it 10 times, you'd see that I would get this 50 down here in the red. What's this thing over here? Well, I'll talk about that in a second. So down here in the red, all right, would give me 7401.22. And so if I just did simple interest, right, principal and interest, it was not going to give me that much. It was going to give me 5,000 times 0.04 times 10 years would give me 2,000. So it would only give me $7,000. But if I compound it annually every year, so I'm earning interest on the now interest, right, I get 7401. And this green number I'm going to talk about in class. This green number over here would be if you compounded it daily. All right. If you compound something daily, right, it's the same formula, A equals P and 1 plus R to the T, but we've got this other function, this other part of it, and the rate itself would be, if you compound it daily, this would be the number of days in a year, since the rate was an annual or yearly rate. The daily rate would be whatever the yearly rate is divided by 365 is typically how they do that. And then the number of times you compound it would be the number of years, which is t, times the number of days in a year. So 365 times t. In our last thing, it would be 5,000 and then 0.04 over 365 is a small number. That's the daily rate, and then we add it to 1, and then we raise it to the 10 times 365, or 3560. So if I do 0.04 divided by 365, alright, I get a really small number, plus 1. I get like 1.001095. But now when I raise that to the 3650, it's going to be a much larger number. So we're going to I want you to, on your calculator, right, the way you'd have to do this is you have to take care of this part first, and then add 1 in the parentheses, and then raise that to the 3650 power, and then finally times by 5,000, and we would get this number in green here, this 745896 number. We're going to expand a little bit more of our discussion on this in class and do some examples. It is a little tricky because you don't have, you haven't bought a house, you haven't bought a car yet, so you don't have the practical experience. But hopefully we'll give you some of this experience so that you'll be able to have some knowledge about that. So that's the notes for this section, and we'll continue in class. Thank you.